you ever wondered what powers an electric vehicle and gives it the ability to drive miles on end without a drop of gasoline? The answer lies in its heart, the EV battery. But did you know that this power source isn't just a single battery, but a whole system packed with cutting-edge technology and precision engineering? Today, we're taking you behind the scenes to explore how these batteries are made from start to finish. This is a story of science, innovation, and human ingenuity. Buckle up and prepare to be amazed by the level of precision, technology, and effort that goes into making EV batteries. Step 1. Mining the raw materials. The journey of an EV battery begins deep within the earth, where essential raw materials like lithium, cobalt, nickel, and graphite are extracted. These materials are the lifeblood of EV batteries, with lithium taking center stage as the key ingredient in lithium-ion batteries. But where do these crucial elements come from? Lithium. Lithium is primarily extracted from two sources: salt flats and hard rock mines. In places like South America's Lithium Triangle, spanning Argentina, Bolivia, and Chile, the extraction process involves pumping lithium-rich brine water from underground reservoirs to the surface. This brine is spread across massive evaporation ponds, where the sun does the work of slowly evaporating the water, leaving behind concentrated lithium salts. This process can take anywhere from 12 to 18 months to complete. Nickel, cobalt, and manganese. These metals are typically mined from underground deposits found in places like the Democratic Republic of Congo for cobalt, Russia, Indonesia, and Canada. Miners extract large quantities of ore, which is then crushed and processed to separate and purify the metals. Nickel is particularly valuable for EV batteries because it boosts energy density, allowing cars to travel longer distances on a single charge. Once the raw materials are extracted, they undergo rigorous purification processes. This step is critical since even trace amounts of impurities can degrade the battery's performance, reduce its lifespan, or increase the risk of malfunction. The purified materials are then shipped to specialized processing plants, ready for the next crucial stage: cathode and anode production. Step 2. Cathode and anode production. At the heart of every EV battery lies the cathode and anode, the two main electrodes that store and release electrical energy. Think of them as the positive and negative terminals of a battery. Cathode production. The cathode is crafted from a precisely engineered mixture of lithium, cobalt, nickel, and manganese. These materials are blended into a fine powder and then mixed with a special binder. The resulting slurry is coated onto aluminum foil, which serves as the conductor for the electric charge. Anode production. The anode, on the other hand, is primarily made of graphite. Similar to the cathode process, the graphite powder is mixed with a binder and coated onto a thin sheet of copper foil. Graphite's structure allows it to store lithium ions during charging, making it a vital component in battery performance. Once coated, both cathode and anode foils are dried, pressed, and cut into precise shapes. These sheets will later be layered together to form the battery's core. Any imperfections in this process, such as uneven coating or air bubbles, can compromise the battery's stability and efficiency. This step requires precision on a microscopic level. Step 3. Cell assembly. With the cathode and anode materials ready, it's time for the most complex and exciting stage: assembling the battery cells. This process is often compared to building a high-tech sandwich, with each layer playing a crucial role. First, a porous separator, made from a thin, flexible membrane, is inserted between the cathode and anode to prevent them from touching. This separator allows lithium ions to flow between the two sides while preventing short circuits. The sandwich is then either wound into a spiral, for cylindrical cells, or stacked flat, for prismatic and pouch cells. Cylindrical cells resemble a tightly wound jelly roll, while pouch and prismatic cells are arranged like flat stacks. This structural difference influences how the cells are used in EV battery packs. Once the assembly is complete, the cells are encased in protective shells. Cylindrical cells are placed in metal canisters, while pouch cells are sealed in flexible, vacuum-sealed pouches. These airtight seals are crucial for keeping moisture and oxygen out, as even a small amount of contamination can affect battery performance and longevity. Step 4. Electrolyte filling. At this stage, the battery cells are still dry and cannot conduct electricity. To activate them, manufacturers inject an electrolyte, a special liquid or gel, into each cell. The electrolyte acts as the bridge that allows lithium ions to move between the anode and cathode during charging and discharging. This process is conducted in a highly controlled, moisture-free environment to prevent contamination. The cells are then soaked to ensure the electrolyte is fully absorbed into the separator, anode, and cathode materials. After soaking, the cells are sealed again to create an airtight environment, ensuring no moisture or oxygen enters. The cells are left to age for a period, allowing the electrolyte to fully integrate with the other components and stabilize the battery's chemical structure. Step 5. Formation and aging. Now it's time to wake up the battery. Unlike flipping a switch, activating a battery is a slow, deliberate process known as formation. During formation, each cell is charged and discharged several times to trigger and stabilize the chemical reactions inside. This process establishes the battery's final capacity, stability, and lifespan. If any cell fails to meet performance standards, it's either reworked or discarded. This step can take several weeks to complete. While aging, each cell is closely monitored. Advanced AI-driven testing systems scan for voltage fluctuations, temperature changes, and capacity issues. Any defective cells are identified and removed to ensure only the highest quality cells continue to the next stage. If you're enjoying the video, then kindly like, share, and subscribe to our channel. Step 6. Battery pack assembly. While individual battery cells are powerful on their own, they're not enough to power an electric vehicle. So, manufacturers combine hundreds, sometimes thousands of these cells to create a battery pack. The cells are placed into specially designed modules. These modules are like mini batteries that are grouped together and connected with high-voltage wiring, sensors, and cooling systems. Cooling is essential to prevent the pack from overheating during use. Each module is tested, and once verified, they're connected together to create the full battery pack. The pack is then placed inside a strong metal or composite casing to protect it from impacts, debris, and extreme weather. This protective shell is crucial for safety, as the pack is often placed beneath the vehicle's floor. Step 7. Quality control and testing. Before an EV battery leaves the factory, it's subjected to an extensive series of quality control tests. Each battery's voltage, capacity, and internal structure are examined. Advanced X-ray machines, ultrasonic scanners, and thermal imaging are used to detect microscopic flaws that could compromise the battery's integrity. The battery pack is also exposed to extreme conditions, such as heat, cold, and vibration, to simulate the harsh environments it will face in an EV. If a battery fails any of these tests, it's either scrapped or sent for rework. Step 8. Final integration into EVs. The final step is to install the battery pack into the electric vehicle. The pack is lifted into the vehicle's chassis and securely bolted into place. Sensors and control units are connected to ensure the battery's health can be monitored in real time. Once installed, the entire vehicle is tested to ensure the battery system works perfectly. Charging, discharging, and energy efficiency are all verified before the EV rolls off the production line and into your driveway. The journey of a battery. From the depths of the earth to the assembly line of a state-of-the-art factory, the process of making an EV battery is one of the most complex manufacturing feats in the world. Each step, from mining raw materials to charging the first cell, is part of a larger mission to create cleaner, more efficient transportation for our future. As you drive your EV, remember that beneath your feet is a marvel of science, technology, and human effort. It's a story of teamwork, precision, and the drive for a better tomorrow. If you've made it this far, congratulations. You now know more about EV batteries than 90% people on the planet. For more behind-the-scenes looks at how everyday products are made, be sure to like, share, and subscribe to our channel. See you in the next one.